Our next agenda is Breakfast Talk on Fast and Fit's COVID-19 from the perspective of biomedical scientists. Together here, we have our moderator, Dr. Sabrina Sukardi, and featuring here our four professional panelists today, who are, firstly, Professor Shaharum Shamsuddin from University Science Malaysia. He is a professor in molecular biology. Associate Professor Dr. Leslie Tan Tien Low from University Putra Malaysia. He is an expert in medical mycology. Dr. Muhammad Ashraf Rostam from International Islamic University Malaysia. He is an expert in the field of cellular signaling and molecular biology. And also we have Dr. Mariam Atslan from University Science Malaysia. She is an expert in cellular immunology. Let's put our hand together and welcome our panelists and moderator. Dr. Sabrina, the floor is yours.
Okay, thank you, Krista. I'm sorry I mute my microphone. Okay, Assalamualaikum and a very good morning. I am Sabrina, your moderator for the Breakfast Talk. Today, we are truly honored to have distinguished guests who are experts in the biomedical science fraternity. From USM, we have Professor Dr. Shaharum Shamsuddin and Dr. Mariam Azlan. From IIUM, we have Assistant Professor Dr. Muhammad Ashraf Rostam and our very own Associate Professor Dr. Leslie Tan. Welcome. Okay, how are you all today? Everybody fine? Everybody
all is well, Dr. Saab.
Fine, doctor.
All is good.
Okay. All right. Stay home, stay cool, stay safe.
It's raining in the morning in Kota Baru today.
Really? Okay. Right. So we will commence with our breakfast talk now. Is that okay with with our distinguished guests? All right. So to start the ball rolling, now the first question is to all speakers. Okay, where do we, as biomedical scientists, fit in this COVID-19 pandemic scenario, especially in terms of diagnostic, research, and advocacy? Maybe we can start with Prof first. Silakan, Prof.
Yeah, thank you very much, Dr. Sabrina. Hi, Prof. Chia, my good friend. You look very young always. I say you need to give me some tips how to keep, my hair, because I have no more black hair. It's gone already.
You look young too.
I used to make a joke. Yeah, when people ask about my age, I told them I was born blonde, so that people think that I'm younger.
My hair is getting gray as well.
Okay. Regarding the questions, to me, biomedical science students, actually, when you graduated as a biomedical scientist, you are everywhere. Either in the diagnostic, of course, diagnostic is totally biomedical work. It is, I think even biotechnologists, they have to fit in the biomedical mothership, because the biotechnology people, they don't learn, they didn't taught how to about disease and also parasites and things like that. The pharmacology part is not there, so it's something which is the mainstream. To me is a blessing in disguise for biomedical science. This COVID-19 pandemic is actually putting, I think, none of our batches, those who have problems finding jobs in the private sector or private, even in the service sector also, they are all hired. Somebody somehow called them to go for a contract job, and after one year and a half, they were absorbed as a permanent staff. Especially those who are from the East Malaysia, from the Sabah and Sarawak, because they are very they are in the need of biomedical scientists. And research is definitely, if you go through the 100, I think we since August 2020, WHO has listed 146 vaccine candidates that has been developed. I think we all know that about 50, more than 50 vaccine has been developed, and then we are using some of them now. I think 3 of them are very famous in Malaysia because we are using, and then another 3 is waiting for the approval by the ministry. So basically, to search for diagnostic research into this is biomedical. Basically, we are indeed in the right place. Advocacy, I have no idea about advocacy because you need LLB law punya this what we call it the qualification. But I think all of our system now, our education system for biomedical, we are already in the process of putting some ethical courses, understanding of the law and things like that, patent, everything has start coming in. I think Prof Jah is in the main frame of designing the curriculum for biomedical science, and indeed, I think he has done a very good job in putting all these law, ethical, and also bioinformatics enhancement to what we call it to equip our graduates to a greater need for the future of Malaysia. That is my point. Thank you.
Thank you, Prof. Shall we hear from Dr. Mariam, please? What are your opinions on this?
Assalamualaikum. Good morning, everyone. It feels good to be back and talking to UPM people because I graduated from UPM back in year 2000.
First batch.
Oh, okay.
Yes, I was your student, Prof. Sabrina.
Oh, ya ke? Ya Allah. That shows how old I am.
Right. Thank you for inviting me. I think biomedical scientists play an important role in helping to actually contribute in terms of knowledge to the community, in terms of knowledge of knowing what is actually the mechanism behind COVID-19 infection. I think every aspect of biomedical science play important role. For example, if you are a bioinformatic person, you need to actually know the sequence, okay, to identify what are the importance, the genomic, the proteomic part of COVID-19. And if you are a pharmacologist, for example, perhaps you can identify what are the important drugs that can actually help to treat COVID-19. If you are an immunologist, you need to know what are the mechanism of COVID-19 so that you can actually design a candidate vaccine. So I think every one of us in the biomedical science play important role to actually help to combat this disease. I think that's all for now.
Thank you, Dr. Mariam. Shall we hear from Dr. Muhammad Ashraf, please? Dr. Muhammad Ashraf from IIUM. Welcome, Doctor.
Dr. Muhammad Ashraf will be a bit late.
Okay, it's all right then. We will hear from Dr. Leslie. Hi, Dr. Leslie.
Dr. Leslie will also be a bit late.
Oh, okay, it's all right then.
Okay.
All right. Then I will go on to the next question. At the moment, most of us do not know how the COVID-19 vaccines work. Because there are 2 types of vaccine, one using mRNA, the other one using attenuated virus. So let's now talk on the mechanism of the vaccines. Okay, how long does it take to build immunity after being vaccinated? Prof?
I would like to invite the alumni of UPM.
Oh, okay.
She was although when she did her master's in my lab, I learned a lot from her on immunology. So
Oh, that's good.
give her opportunity to explain first. I will follow through. No, don't worry.
Okay. Make me very proud. Dr. Maria, sila.
Okay. All right. When we talk about immunity, okay, vaccine immunity, okay, I'll give an example. If we buy, for example, we buy a bread, okay, normally we check the expiry date.
Yes.
Okay, but to test the actual expiry date, we need to actually wait until some fungus appears on the bread, so that we know what is the timeline of how the bread will expire. So therefore,
Okay.
to know when something will last, we need to actually track the timeline. And similar to vaccine, we don't know exactly how long it will last until we track them from now. So it has been reported in Science journal that COVID vaccine can actually last up to 8 months. Okay? Although the immune memory is what leads to the long-term immunity, it is actually hard to predict how long the immunity will last, because the exact mechanism of protective immunity used by our bodies are not known. So until we actually reach the time point of we can track the vaccine, we don't know the exact time. But if we start from now, we can actually track the immunity towards the vaccine, because the vaccine was available in December 2020. Okay, so not even 1 year. So it will take some time to actually we know how long it can protect us. But for now, we know that the vaccine can protect us from COVID-19 infection. But do we need a booster after this? Like if we have been vaccinated with 2 doses, do we need a booster? That is a question mark. So research has been done in this area, and we in USM have also started a research to actually track how long the immunity in our body will last towards COVID-19. And we plan to track up to 1.5 years. So I think that is still a question mark over there.
And I am the guinea pig. I gave my blood to Dr. Mariam. Yeah, I think all the management here gave the blood just to make sure the project is successful, because they are actually looking into the immunological response factors after the before, after the first dose, and then after the second dose, and then further I think a few weeks more after the second dose.
We plan, what we have done is actually to take blood from before the vaccination, before the first dose, and then before the second dose, and followed by 2 weeks after the second dose, 6 months after the second dose, and 1.5 years after the second dose. So there are 5 time points altogether. So then we can track whether the memory towards the infection has upregulated, and we also will track the antibody, the neutralizing antibody towards the virus itself.
Okay, just a little bit to add on that, just to ask, what type of vaccines are you giving your subjects?
I took Sinovac.
Okay, Sinovac is what type of vaccine, doctor?
It's inactivated.
Oh, inactivated.
Sinovac is from CoronaVac. It's a China company. I think not many people can get Sinovac those days because it's just given to people with having problem with what we call it, if you have a history of being in the CCU, you know, have some problem with clotting problem. So I was one of them lah. Normally, also my hair is blonde, but I had experience in the CCU. So they just remove my name from Pfizer. They put on Sinovac.
I see. Okay. Welcome our two distinguished
Dr.
speakers,
Leslie,
Dr. Leslie and Dr. Muhammad Ashraf. Welcome.
Dr. Ashraf, how are you?
Alhamdulillah, good. Thank you, Prof. Thank you. Thank you, Doctor.
Morning, everyone.
Okay, hello. Assalamualaikum, Dr. Muhammad Ashraf. Right, the first question we all dah tanya just now is where in your opinion, the two of you, do we biomedical scientists fit in research, diagnostic and advocacy of the current COVID-19 pandemic? So these two questions have been posed to our speakers from USM. So I'm posing these two questions to you now. So maybe we can start with Dr. Ashraf.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I apologize because I thought that the session would start at 10:15. So it started earlier, is it? So
yeah, a bit early, yeah.
Okay. So with regards to the question, first and foremost, thank you to the organizer for inviting me. Yes, regard to biomedical science, I would first put a disclaimer to my own self. My PhD is in biomedical science. Okay, my degree is in medical lab technology. Nevertheless, I'm now being kind of abducted by the Department of Nutrition Science. So I'm no longer teaching biomedical science students. So mostly I'm teaching nutrition sciences students are those who are going to be dietetics. But obviously my passion has always been into biomedical science. Now, with regards to what we can involve as a biomedical science, personally to me, I think maybe I'm assuming that the first two speakers have mentioned about research. I myself now am involved actively in as the chief or the head task force of our kuliah. Kuliah in UAE we refer to as a faculty. So at the same time, I'm the member of the campus in Kuantan COVID committee. So for your information, we have weekly meetings since the start of the pandemic, twice a week. So it starts at 8:30. So now actually this morning we had the meeting. So our meeting now it's becoming a bit more shorter because of the reduced cases and so on. But we have been doing this since last year. So it shows how much of the cases and the dynamics of this pandemic, and there's always something new. So we as a biomedical science, so that is where I'm leading this team, with regards to some of my experience as the health and safety committee in our kuliah, in our faculty. So that is one. So with regards, we can become a part of a task force for this pandemic, COVID-19. And at the same time, I myself do actively participate in advocacy programs. I myself have a YouTube channel, Facebook. All these are trying to provide people with evidence-based information and hopefully clears up some misconception or misunderstanding. I think we hopefully we believe we are the learned people. We cannot say that those people don't know and understand. I think we have the responsibility to provide with the correct knowledge. So I think that's kind of to kickstart with the discussion, two of the things on my personal part. Thank you.
Okay, thank you, Dr. Muhammad Ashraf. What about Dr. Leslie? Do you have your opinions on this?
Good morning.
Advocacy. Yeah.
Yeah, good morning, Dr. Sabrina, and good morning to the organizing committee for inviting me to have some sharing on this morning breakfast talk. So I'm really appreciative of the effort that is being taken to promote this COVID-19 awareness. Personally, myself as a biomedical scientist, like Dr. Ashraf, I'm not really into biomedical in general, but into the sub-discipline of one of the biomedical disciplines. Like I'm actually into microbiology now, so which is more pertinent to the topic that we are talking about. But having said that, personally, I've involved myself from the beginning last year in March, April, where we started to get a bit panicked when COVID-19 pandemic affect our country. So we were establishing our diagnostic lab in our teaching hospital in HP UPM. So that was the time when a lot of uncertainties, we are having a lot of uncertainties. Everyone is like so suspicious of each other. So we are so highly like paranoid, like, oh, am I doing the right thing? Because we do not have much information then. But since then, I think there are lots of information now. There are more, but having said that, also there are still more to actually discover. So being a biomedical student or being a biomedical graduate, actually the whole is a playground for you now actually to explore whichever disciplines that you are in right now. So whether you are in pharmaco, whether you are in microbiology, whether you are in nutrition, there are all these are actually sub-branch of what we learned during my biomedical degree time. So what we can do is actually, because we have the added advantage of looking at things from the multidisciplinary approach. So that gives us a wholesome, holistic view of looking at this current pandemic. So I'm sure that things like looking for therapeutics, looking for like what Dr. Mariam and Dr. Sharum are involved in, looking at the protective protective of the current vaccines that have been given. So all these are lots of the other potentials. There are many things we can explore in, like even looking into improving the diagnostic, because right now, yeah, POCT is the key, where we don't really need to go to the lab to actually do the testing. So for biomedical, I'm very confident that we are very, very much equipped with all this knowledge to venture into any of this part of studies that we can eventually help in overcoming the current pandemic. Even epidemiological studies, field studies, I think we are also equipped with the necessary skills and knowledge in addressing our current pandemic issue. Yeah, so that's my current opinion on yeah, it is up for us to think out of the box and to venture and to be more curious about the situation that we are having right now.
Yeah. Okay, thank you, Dr. Leslie. It seems that the current pandemic situation is a blessing in disguise for biomedical scientists in a way, because we get to see what we learned so far is all happening right now.
Correct. Yeah.
Yeah, all branches of biomedical science is actually happening now. Then we can see it with our eyes. How important.
And then I tell you what, after this, they are looking for biomedical graduates to do vaccine in Malaysia. I'm telling you, within 6 or 1 year, our student will be, it's just like goreng pisang. I mean, goreng pisang panas.
Yeah, yeah.
Okay, inshallah. Right. So, to go on to the second question, which I have asked Prof. Shahrukh and Dr. Mariam, I would like to pose this question to you. The USM is doing a research on Sinovac vaccine. Okay, so that one is a attenuated virus, betul kan, Prof. Shahrukh? Attenuated, kan? Yes. Okay.
Sinovac
and also Pfizer and Pfizer.
Mostly Pfizer.
Oh, mostly Pfizer.
Saya je on.
Right. Okay, okay, right. So, can you please explain? I'll start with apa tadi Dr. Mariam dah explain, Prof. Shahrukh dah explain. Can I start first with Dr. Muhammad Rustam? How do COVID-19 vaccines work? The first one, mRNA vaccine. The second one, the attenuated vaccine. How do they work?
Okay, Assalamualaikum, thank you, Dr. Sabrina. I think I'd like to provide the very general understanding approach to the disease. Two ways of approach to disease: preventive measures or treatment. And as we know that this COVID-19 is a communicable disease, and one of the best and efficient ways to tackle communicable disease is preventing the domino effect. So that's where the preventive medicine comes in. So vaccine is one of the best ways of preventive medicine. So what does this vaccine do? How does it work? It works together along with our body. Our body, they play that tag team. And how does it work? The vaccine enters the body and induces the body or stimulates the body to trigger a certain response, which we understand as the immune system. And this immune system responds by first, there's three things: recognize, then produce, and then remember. So recognize, produce, and remember. So it recognizes the specific trigger, either we say germs or bacteria or virals, and specifically towards the antigen that produces or creates that particular disease. And for the COVID-19, it would be the spike protein. Second would be the production of the antibodies. So the body then produces specific antibodies towards that particular antigen and then the virus. And finally, our body has the capability to remember this, the memory cells. So these three things would then, whenever we, after completion of this, we call it the complete immunity. Whenever we get the real infection, that's where our body is prepared, and then we will be safe. Because when people say, why not just allow natural purposes? Well, what we are afraid is that our body takes time to develop this. It's kind of the R&D, and in the middle of that process, somehow if there's a curse of serious adverse effects due to that virus, tak sempat lah, we didn't make it, and our body, fatality, leads to fatality. So with regards to each vaccine, different methods, I think this would be discussed further, or the other speakers have discussed. So that's kind of the of how vaccine works. It's kind of the best embodiment of the proverb of prevention is better than cure. So I think that's kind of my take on this.
Okay, thank you, Dr. Muhammad Rustam. Okay, Dr. Leslie, any opinions?
Yeah, I think basically Dr. Ashraf has covered basically the general idea of the vaccine or how vaccine works. So it's the difference is just the different vaccines have different a way of triggering the immunogenicity of and then the immune response, hence our immune response in the body. So some uses protein, some uses genetic material, some uses the whole virus. So basically there are good and bad in inducing this immunogenicity in the body. So of course there are some claim that because some of the types of the vaccine like includes that the using parts and also the genetic materials, they are quite restrictive in the sense that it only targets the spike protein, and it's like the whole, if we don't really know how our body responds to all these parts, so-called, as well as the genetic material, which are mainly targeting on this spike protein. So what the other protein, the other types of vaccine offers is like, let's say, for example, the Sinovac vaccine, it is an inactivated vaccine. So it is more wholesome in the sense that the immune system may be able to recognize different epitope, and then hence different types of antibodies may be produced, and more chances, and logically speaking, you will expect to have a better immune response, or maybe a sustained immunity. We do not know, but like what Dr. Mariam, I just entered, I think the sustained immunity is the one that we are looking for. But if let's say that thing doesn't happen, so we still need to have booster dose and all that. And another thing that need to touch on is actually the mutants. So the mutants and the variants that are having right now. So some of these vaccines are actually developed based on the mutants that are on the earlier part of the pandemic. So the protective and the immunogenicity may not be able to cover most. I don't know. There are so many things that we still do not know, because we do not have the data, because the period that we have because I think the first vaccine was given in late last year, and so we are in first half of the year, so we don't really need to have some time to actually evaluate and all that. Yeah, so I think to answer the question, basically is like what Dr. Ashraf has mentioned. So it's basically the immunogen. It triggers the protein, and then after which it will be taken up by the antigen presenting cells, which will later be presented to the T cell and B cell, antibody production and memory cell, and so on and so forth. This is basically the immunology part of vaccine. Yeah.
Okay, thank you, Dr. Leslie. Okay, we have a question in the chat box. Here is from Kawayu. He asked, Good day, doctor. I would like to know your opinion about the mix and match COVID shots. Can anybody answer that, or can
Again, what was that? Mix and match?
Mix and match vaccine shots, COVID shots.
Okay. Can I say something about this?
Yes, please.
First of all, we have to, with all due respect to the molecular biology and also the vaccinology, they had put their best. You see, there is no way, because the first infection of COVID was December 2019, yeah, and we are not even December, not even November 2021. You see, normally a vaccine, a proper vaccine production, you know, to fulfill the needs, it will take like 4-5 years. I think Dr. Mariam know best. If I say 4 or 3, she will smile because she know that I'm joking. This COVID vaccine, they make it, you know, to be used within, I think, not even 2 years. So I would like to compare, you know, they just look at the cousin of COVID-19. You see, COVID-19 is coronavirus. If you look at the family tree of virus is divided into 2 kinds. One is DNA virus. We are talking about RNA virus. Coronavirus and flu virus are RNA virus. We have a lot of information about flu virus. That's why I have spent many years in the Veterinary Services Research Institute when I was in the GPS before. We have been with war with this influenza for many years, and then we are, you know, if we look at influenza, every time you want to go for Umrah, you have to take jab, you know. If you don't take jab, they won't allow you a visa. Is it? And then if you look at the component of the vaccine of influenza, they have bivalent, and now they are making like trivalent, and might go into 4. Is it? So they are basically mixing. And I'm not going to say it, you know, it's gonna be like the same like influenza, but it seems that because we heard that a few weeks ago, people were talking about, you know, I think there is a report in Europe, one of the country, they start jabbing a mixture between Pfizer and also AstraZeneca. So this kind of thing is undergoing procedure and in research in the testing. So we just have to follow what the authorities say lah. That is my opinion lah to the question. Thank you.
What about you, Dr. Maria?
Yeah.
Sorry, Dr. Maria, what about you? The mix and match?
In immunology, actually, we call this as a prime boost strategy. A prime and then boost strategy, and actually it is not a new strategy because here in ESM we have a TB vaccine research, and we actually practice this prime boost strategy where we prime with BCG, the common vaccine for tuberculosis, and then we boost with our own candidate vaccine. It is actually quite common, but currently for the COVID-19 infection, I think further research is needed to actually identify what is the best approach that we can use to combat this disease. Otherwise, I think we need to stick to the current plan to vaccinate as many as possible. But at the same time, we also continue to do research on this area.
I see. Okay, any thoughts on that, Dr. Muhammad Ashraf?
Yeah, thank you, Dr. Sabrina. I'd like to echo what Prof. Sharon has mentioned about the European study. I think among the three kind of important studies that even the Canadian Advisory for National Immunization has picked on, I mean, used as a reference, is the Spain study, the German study, as well as, I can't remember the other one study. But these three studies kind of puts the basis towards their announcement of allowing or supporting this heterologous prime boost strategy, which bahasa layman term would be the mixed match, or some people, somehow the Malaysia, the netizens say rojak-rojak, somehow macam Malaysia nak rojak, DKJ mention is kind of not without any basis or evidence. Nevertheless, this has been kind of the debates, the trend, looking into the data of heterologous inoculation. You need to say 2 different doses using difference. And mostly is all the studies at the moment have been looking at AstraZeneca as the first dose. The second is mRNA vaccines, either Pfizer or Moderna. And the interesting thing is that there's 2 things. I'll start with the good thing. The good thing is that most of the studies, the UK study has not produced the data on immunogenicity. They have given reactogenicity. For immunogenicity, this method of heterologous inoculation has provided effectiveness towards the variants of concern. This includes the, I think it's the alpha, gamma, and I can't remember the variants, but one of the 3 among the 4 variants of concern.
Delta.
And that's good.
One.
Delta, is it? Yeah. So that's very good. So another thing is that it induces stronger kind of efficacy. And the other one, nevertheless, with regards to reactogenicity. So this is the data that has provided by the UK study, whereby they looked at all the reactogenicity, systemic as well as local. So interestingly, there were 4 groups involved. So 2 were homologous inoculation, Astra, Pfizer. The other one will be Astra, Pfizer, or the other way around. And what they found is that those who were given heterologous immunization had higher reactogenicity. I think it was specifically the body aches, malaise, headaches, compared to those who got homologous. So with regards to reactogenicity, there is kind of, well, it's not that adverse side effect, it's just those normal side effects. There is a bit of data showing it's a bit more stronger, but for the immunogenicity, there is obviously data showing there's something good. So now, as I mentioned, this is just for the Astra as being first. And yeah, obviously because the problem statement when all these data were conducted is because of the blood clot issue and so on. So that's, I think, one of the data that we can look into.
I see. Thank you, Dr. Muhammad Ashraf. Any thoughts on that, Dr. Leslie?
I think Dr. Ashraf has put it very well. I mean, put it very well and explain it very well. So in the sense that, yeah, of course, the chances of you, because they are targeting like AstraZeneca and or Pfizer vaccine, they are based on different types of vaccine. So one is viral vector vaccine, and the other one is the genetic material, which is an mRNA. So naturally, our body will definitely have a better recognition of the different epitopes from these 2 types of vaccine. So the chances of having a higher protective or so-called efficacy is, of course, naturally there. But of course, like also Dr. Ashraf has mentioned, that the downside of it is, of course, you will see a slightly, I do not want to use the word severe side effects, but no pain, no gain, right? So I think that can somehow sum it up. But it will not cause any severe disease until you need to go to ICU or even be in inpatient in the hospital. No, I don't think you will need to go until that level. But of course, like maybe it's just like any other demam or whatever that we normally experience. So I don't think, to me, in my personal opinion, as long as the safety is established, I think mix and match vaccine is a way to go. Yeah.
Okay, for the moment, our government is not practicing it. I don't think
they are looking at it, but I think
yeah.
Well, our government is a little conservative, so which is actually good for us.
Okay, right. So our alternate questions between the chat box and the questions that we have prepared. So in the chat box, there are a lot of questions talking about the vaccines that we receive. They are asking how long we can be protected. Let's say, has there been studies on AstraZeneca, on Pfizer, on Sinovac? How long after the first dose, second dose? That is the first question. And the second question is, why are there different durations between different vaccines? Contohnya for Pfizer is 21 days apart. For AstraZeneca, it's about 8 to 12 weeks apart. Why is there such a duration? So there are two questions there. So can I start with maybe Prof? Prof,
I always give those questions to Dr. Mariam.
Okay, then we ask Dr. Mariam. Nakal Prof doh. Okay, Dr. Mariam, sila.
So the question was why we have different immune response and different duration
Yes.
the vaccine. Okay, basically we need to understand how our body works. Okay, when anything or any invaders attack our body, okay, they will actually invade into our body and then they start to replicate and multiply. Okay, so this invasion is called an infection, which can cause illness. So our immune system will actually uses several tools to fight infection. And what is important is the white blood cells in our blood, which help to actually fight this infection. So as we know, when we get a vaccine, okay, it actually mimics the actual infection. So when it mimics the actual infection, it will send a message to our white blood cells to produce antibody to fight the infection. So and then the antibody will be produced. So if you, I'm sure the biomedical students have learned about this. So you have a prime after infection. So you will get a slight increase of antibody, okay? And then you need actually a second booster to actually boost the antibody production so that the antibody production will increase. So, and then the level of antibody will maintain. So I guess why different vaccine have different prime and boost time, and also there's a vaccine that actually requires only one dose. Okay, so I think that it depends on the research that they have done before they actually release the vaccine. So they have actually tested the antibody response of the participant in those studies, and from there they can actually determine what is the exact time point that we can give a booster to the people.
Okay, thank you, Dr. Mariam. Anything to
I
add?
just want to echo. Yeah, okay. I can echo. Yeah. After the proper academic explanation by Dr. Mariam, I will just add some rubbish. Okay, we are having 33 approved WHO vaccine at the moment. Out of that, we have most of the vaccines are with 2 doses. They have one vaccine with 3 doses, which is based on DNA plasmid, and then they have 4 vaccine, which is 1 dose. Actually, Oxford AstraZeneca, which is developed by Jenner Institute in London, in UK, was actually meant for single dose. Single dose. So it was listed as a single dose vaccine under WHO. Including also the CanSino. You know the CanSino, the one that the Malaysian government is going to use for the orang asli, to make sure, so that you don't need to go twice into the post bala, post ni. It's good lah. I mean, and then it can store at a good temperature. So so this is the thing. And then other than that, I think if Malaysia want to venture into this, I mean, the local production of vaccines, we have to look into the best, you know, that can be used for local people. We need to think about everybody, not only people, you know, in urban saja. you have to think about the people in Bomusang, in Likas, in Sandakan, Lahad Datu. So those kind of things. I mean, the people up there to looking into this. That's all my information. I mean,
Yeah, thank you, Prof. Okay, it's a good idea to have only one single dose. Just to go to that vaccination place itself is frightening for some people. To go twice is even more frightening. Okay, to add on that, Dr. Muhammad Ashraf, to add on why certain vaccines we need both, we need 2 doses, why certain vaccines we need 1, and what is the duration such?
Yeah, thank you, Sabrina, Dr. Mariam, and Prof. Jarum have mentioned very in depth. And I think these are all of these are based on the data that was given or the data that has been published in different kind of location in with regards to different types of subjects or respondents. And these have been used as a guideline for this kind of range. And all of the different vaccines provide different kind of range. But at the moment, all has been within the range of 3 to 4 weeks. AstraZeneca takes a bit more longer, 4 to, I think it was 8 to 12 weeks for the second dose to be inoculated. And there's been studied that the longer we wait or delay, the better kind of our immune response towards the production of the antibodies. So the question is why it has been discussed. Nevertheless, the thing that we maybe just to add on is that with regards to the length we need to tell the public that it's not doesn't show that the drug is not the vaccine is not good or have less efficacy or so on, because it shows that if we follow this range, most of the time it provides that particular immunogenicity has been shown in the clinical trials. For example, the AstraZeneca gets a bit slower with regards to production of antibodies compared to Pfizer. It speeds up a bit earlier, but after 4 weeks, quite similar. But for second dose vaccination, most of the vaccines after 2 weeks, it provides 99% of the kind of the seropositivity rates. So this is the thing that we need to really add on. If people ask, well, that is not a factor to say that, oh, AstraZeneca is a cheap vaccine, tak nak pakai. So it's kind of that's my point.
Okay, thank you, Dr. Muhammad Ashraf. Dr. Leslie, anything to add to the question, duration, and types of vaccine?
Yeah, I think if I just like to switch the table around. If let's say we were the vaccine producer or vaccine designer or whatever that you would like to call yourself. So I think this, if you are thrown into such a situation, I think you can just base on previous data on other type of vaccine and fall back on this period of time, whether it should be 3 weeks, whether it should be 3 months or a different type of protein. So I think based on the type of vaccine that they are being produced, so I think a good intelligent guess is just to fall back into whatever that we have previously and to just, I don't think there is any exact figure, but I think it will also depends on maybe the community itself and the variants that are actually being circulating in that particular community. So there is no magic number, but I think the range that is given is a safe range. So and then to answer the question, how long will we be protected? So there are I don't dare to give you a specific figure because I don't think we now, because we are only into our 6th month of having the vaccine, so we practically do not know how long it will be protective to us. So the basic idea, the bottom line is still to, even though we are fully vaccinated, we should always protect ourselves by keeping and sticking to our SOPs and all that. So physical distancing, always wash our hands and all that. So yeah, so that is to answer the question of how long and why the different duration for the first and the second doses.
Okay, thank you, Dr. Leslie. Now there are a lot of questions in the chat box. One question that caught my eye is from Prof. Chia. He asked, do you think that after all the vaccination, the virus later may become even more stronger and we need to develop another vaccine? Can we pose that question? Prof, saya tanya Dr. Maria dulu.
Okay, thank you.
Okay.
Actually, that is a difficult question because the answer is that we don't know actually. The bottom line is not everyone has been vaccinated until now. So until we reach that herd immunity, it is difficult to actually predict whether the vaccine is effective or not, or whether they are resistant to certain variants. Those are actually still a question mark, and I can't actually give a clear answer to that. But I guess we need to ensure that everyone get vaccinated. That's the first stage, and then we can plan after that what we will do following those vaccination. And I guess because we also get different vaccines, so that's another question, how long that can protect us. For example, Prof. Sharom, he got Sinovac, and maybe most of us got Pfizer. So that is a question mark as well. So and it also depends on the nature of our body. Okay, if you have comorbidities, okay, your immune response might be different. So it's actually very custom made. There is no right or wrong to this. So it really depends on the time, and we hope that by doing more research, we can get answers to all those questions.
Okay, thank you.
I will just echo what Dr. Mariam was saying. Kita ikut orang muda lah.
Okay.
Well, we have some discussion with my colleague at the Febra Institute London, Virology Institute in UK, and also Dr. Azai Bitami from the CDC Atlanta. I was looking into his ideas, what is actually happening to this variant. So this is a problem. All scientists, even in the developed country, they cannot say, they cannot put their feet down. And the only things that they can say, just like Dr. Maria was saying just now, it depends on the totally, because infectivity, kejangkitan, kebolehjangkitan, and also the severity of the jangkitan is actually mainly based on the ability of host interaction with the virus. So if you learn pharmacology, there is one area in pharmacology, we call it pharmacogenomics. I think one of our lecturer in UPM was the expert in pharmacogenomics. So this pharmacogenomics is actually they are looking into how they develop personalized medicine. Personalized medicine is just meant for him because of his genome can only tolerate certain drugs. So those kind of things is the same. It's the same because when you deal with people, you cannot see what is the capability that embedded in the gene, in the genome of that person. Vaccination is just like random enhancement of our immune system. That's why you can have people, like me, after I get my Sinovac, nothing happened. I just asked the person who jabbed me whether you really jabbed, at the correct clinic. I didn't feel anything. But the second jab is a bit, you can feel the pain. You see? So after that, I told him, I hope there will be no more third jab. But whatever it is, it's something which is you cannot answer unless you produce a very thorough research, with a background, with control, and we are waiting. We are waiting for WHO, the CDC, and also PKM, our clinical research institute to really look into this. Thank you.
Okay, thank you, Prof. Dr. Muhammad Rostam, would you like to add on to that?
So regarding the how long the immune system as well as the variants. Yes, the data is still not there, but I think to look into the virology aspect of these viruses, coronavirus are RNA virus. One of the things that creates these vaccines is due to mutation, and RNA viruses are a bit more kind of easier to get vaccinated, change kind of to become all these variants. So that we might be able to not predict a project. I mean, just looking at the previous vaccines. Influenza virus, which is highly mutated, needs a yearly dose. The meningococcal, those who go for Hajj, saya belum from maybe dah. You need to go for that one would be about 5 years, I think, and then there will be a new. You need to be inoculated for a booster. Measles and MMR would be a lifetime, but measles are still RNA virus also. So that is another question. So, but just to mention about the things that we can have a look and have some kind of projection, looking at the data of previous kind of viruses that are available. So nevertheless, with regards to this, even though there are these mutations that is now leading towards all these variants, I think among the things that we can be reassured is the mRNA vaccine technology. Because due to the mRNA vaccine technology, it's a bit more of a kind of, we can have a faster vaccine development. You have the template for the subunit of the antigen, or if it evolves, and then you have the sequence, you enter, and then you create a new, the antigen for the vaccine. So hence, be rest assured, it will not be that kind of a disaster. So I think that's kind of my take on it.
Okay, thank you, Dr. Muhammad Ashraf. Dr. Leslie, anything to add on to the question?
Yeah, thank you, Dr. Sabrina. So thank you to all the previous explanation by the panelists. So there are a few perspectives that we can look into actually on with regards to the question on whether we need to actually have another. The question is on after all the vaccination, the virus later becomes even stronger. We need to develop another vaccine. I think it's all. The first thing that we need to look into is why is it important? It's because right now it is pandemic. So when it's pandemic, it happens throughout the whole global arena. So basically, so the race is the key here is time. So if you develop the current vaccine is to address the current variant. So the current variant, you are protected of the current variant. So, but then what we see is there are many variants that are coming out. But of course, this variant have not shown. Actually, some studies actually have talked about increase in severity. So it's simply because it's the race against against the virus. So if the vaccination rate actually goes up higher than the virus is able to be transmitted and also mutated as a result, because when it transmits from one person to another person and it undergoes replication and all that. So when you know that replication happens, sometimes you have errors in the replication. So when that happens, so that is why it causes a variant and the change in the spike protein or all the other proteins but the spike protein is the most fluid protein compared to the other proteins. So it basically boils down to how fast we can actually vaccinate. So that's why there is also the idea of mix and match. So mix and match actually give an enhanced coverage of the different antigen and epitopes that are recognized by our immune system. So to answer briefly whether there is a need for a vaccine, it really boils down to the time. So we are able to vaccinate the whole world in a timely manner before giving any opportunity or chance for the virus to mutate, then we will win. If not, we will keep on seeing. But also on the other hand, having said all this, we also hope that it will just die off by itself, even though it may be highly transmissible, but maybe the severity is not high. And that is actually happened to some of the viruses that in previously where they just die off, like what COVID-1 you like to call it, So it just dies off by itself after some time, even though the mortality rate is so high. But we really, really hope that for SARS-CoV-2, we also hope that by this mutation that takes instead of enhancing them to become to have more severe effects on patients, we hope that it actually becomes more becomes weaker. So and thus it will just be I so-called write off from our book, and yeah, we just consider it as another episode in our lifetime. So I think it basically is that the time is critical here. So that's why we need cooperation from all the different countries, especially Western. Our minister have been complaining that they have been holding the stockpile of the virus, the vaccine. So we are suffering, especially in the third world countries and also the developing countries, because our vaccination rate is very low, not very low, not at the expected rate that we want it to be. So so it is actually the time that is the critical part here.
Yeah, that's true, Dr. Leslie, but time is the essence. Okay, I have a lot of questions here, so I'm going to pick the ones that is relevant to what we are talking now. So the two questions that I see is relevant is regarding the vaccines that can cause thrombotic event, thrombosis. That's the first one. And the second one is, which one of the vaccines that I have given now can cause a person to become less infectious? Maksudnya, people has been vaccinated, but they still get COVID-19. So there are two questions that I'm posing here. One is the vaccines that cause thrombosis. Why? The second one is, once you have been vaccinated, can you still become infected? So I'll start off with, Prof nak start dulu ke? Ya, so Dr. Mariam dulu. Okay, Dr. Mariam, let's hear your views.
Okay, thank you, Prof. Okay, we need to actually understand that when you have a vaccine, you are not wearing any bulletproof. So vaccine is not a bulletproof towards any infection. Okay. In terms of the risk of blood clots, anything that you take can actually have a slight risk of blood clots. Okay, for example, here, if you take AstraZeneca vaccine, there is 4 cases of blood clots in 1 million who have been vaccinated. So that is 0.0004%. Okay. For women, if they take contraceptive pills, okay, they have a risk of getting blood clot in 0.05%, which is higher than taking AstraZeneca. And people who smoke, they have a percentage of developing blood clots in 0.18%. And more severe, if you have COVID infection, you will get 16.5% chances of blood clots. So to talk about the risk of blood clots, everything can give you a risk of blood clots. Okay, but how many percentage of that blood clots can occur? And in COVID infection, you will get a higher chances of blood clots compared to if you get a vaccine. So I think that all the myths that we need to actually put aside, and we need to focus on the vaccination itself. And the second question was that which vaccine is more effective than another? I think that is a dangerous question to answer, because that will actually we will become biased. That is why the government they didn't allow us to choose any vaccine, because people will say that Pfizer may be a high-end vaccine, while Sinovac made in China not a good vaccine. So I think that is not a chance for us to actually select any vaccine. There is no chance actually. But in terms of effectiveness, I guess all vaccines are effective. we never questioned where we got our BCG vaccine from. Okay, when we were young, okay, we got BCG vaccine, but we never care about who is the developer, right? So I think the most important thing is that get the vaccine, okay, and don't worry about the type of vaccine, because different people actually respond differently to different type of vaccine. Some people, they develop fever after getting the second dose of Pfizer, while some people, they are still healthy after getting the second dose. So there is no clear answer to that. I pass to to Prof. Shahrul.
Yeah, just want to echo the expert was saying. Okay, that's why we are very lucky because we live in Malaysia. You see, apa ni KPKM, the Ketua Pengarah Kesihatan Malaysia, di Hisham, Tan Sri Hisham. He's a very concerned person. You see, he produced a notice to the whole medical facilities in under KKM on 14th of April, just to make sure, you know, to state down those people with blood clotting problem at certain level, they have to abide certain rules. They have to go and see the specialist. You know, they have to bring the material, I mean the drugs that they are taking to the medical officer to check. Even for those who are having anaphylaxis, this anaphylaxis problem, they also will be considered, you know, they need to consult people. So to consult the medical specialist. I got some outsider call, okay, that's why interrupt my attention a bit. Sorry, yeah. So that is the thing. So do not concern much about which vaccine is efficient, but just get the vaccination. So we are very lucky to have KKN DG who is concerned about this, and then looking at the history, you know, even we go and see, and the doctor was saying, you know, after you reach PPV, there are 3 layers. The first, you go, you check the, you know, the pegawai rela, you know, check the IC, and then you see the nurse. The nurse will go and check your BP, everything. If the BP above certain level, you cannot go. You cannot get injected, you know. They ask you to go back and come later in other days. So we are very, you know, very soft. And then there is no compulsory. Tak wajib. Vaccination is basically kita panggil sukarela. Tak ada pun tentera datang untuk paksa vaksin tadi. So this is the thing. Based on I just want to tambah sikit efficacy that has been published by the WHO. Sinovac is 60% and above. The Pfizer is 94% and above. So that is the efficacy that has been reported by WHO. Itu saja.
I see. Thank you, Prof. Thank you. So yang untuk AZ tak ada lagi efficacy?
Ada juga, ada 90 something juga. Dia about the same with Pfizer.
I see.
Prof, saya nak tambah sikit. I would like to add about the efficacy. Actually, we need to know how to differentiate between efficacy and effectiveness. Those are two different things. When we say efficacy, it actually happens during the testing of the vaccine. So what they have done is actually to give the vaccine to one group, and they have another control group who received the placebo. So they then compare how many of the vaccinated versus the placebo who got infected. And that's how they actually calculate the efficacy. But in terms of effectiveness, it's how effective the vaccine in the actual community when you give to the public. So I guess we cannot just rely on the efficacy, but we also need to look at the effectiveness, because efficacy is a controlled environment. And when we give the vaccine to the public, it is a uncontrolled environment. So I guess in terms of effectiveness, nobody died after getting any of those vaccines. So as long as we are concerned, those vaccines are all safe.
Okay, thank you, Dr. Mariam. Would you like to add anything on that, Dr. Muhammad Ashraf?
Yeah, okay. Regarding the blood clot, I think Dr. Mariam and Prof. Sharom has given some of the reassurance and kind of what we should do. I would like to take back to, because the question was which vaccine created the blood clot. So I want to put into a bit of the academic, and so that the students also can learn. I want to go on to the sekiranya masakan pokok bergoyang. So kind of that. So apa angin itu? So I want to bring into the case of blood clot. This is a true data, and a bit I'll take some chronology very briefly. When they conducted the AstraZeneca, somewhere about September, the clinical trial stopped, halted, because there were cases of blood clot. Now, then somehow they found out it was safe. They continued doing that about December until March, when they were safe to use. Even the EMA, or the European Medicine Agency, announced that AstraZeneca is safe. Now, what happened was, Prof mentioned just now, pada April, the DG had mentioned regarding reporting of the symptoms. On somewhere mid-April, the EMA published in their website saying that the new statement is that you need AstraZeneca. It's somewhere like EMA safety announcement says that concludes that there is unusual blood clot with low blood platelets together with the condition should be listed as a very rare side effect. And this also responds to what Dr. Mariam has mentioned. It's a very rare side effect. But nevertheless, the highlight here is EMA announced this, showing that in all countries, we have now concluded that this is something true, but so saying that it's very rare side effect. Now, what happened and what impacted to the whole world? There were many countries to halt. There were countries that recommended limitation. Okay, now only 60 years and above can take AstraZeneca. There were, so for example, these were mostly the European countries. Okay, 60 and above is because most of the cases that saw this kind of blood clot occurred for those who were 60 and below. So now all those countries halted and only limited or recommended those 60 and above to take AstraZeneca. There were countries that just didn't allow even their citizens to take AstraZeneca. Now, what happened is that maybe we'll take some facts into those our neighbors. Philippines were amongst those announced the halt of their AstraZeneca for the second dose, particularly. What happened? About 20 days, they stopped this using AstraZeneca. They continued, they uplifted that kind of limitation. If they feel that we have now jabbed about 500,000 of our citizens and there's no such side effect, and then they continued. So in a demography kind of situation, we look, our neighboring countries has no side effects. Side effects in clinical trials, as well as some of the cases reported in the UK. I want to refer to the cases that was that highlighted in the EMA review. They concluded based on 50 cases, 62 cases were blood clots occurring in the brain. About 20 cases were blood clots somewhere in the abdomen, and 18 deaths due to this. And this is why they conclude all this. But and that's the reason whereby, as Prof has mentioned, the symptoms that we need to monitor are, for example, if prolonged headache. So this might be an indicator or red flag of the blood clot in the head. Another thing is about the abdomen. If there's any kind of abdominal pain, prolonged, the red flags. And others, including if you under this underlying skin, there's kind of pecah darah pecah kan. So that's among the indicators of red flags. So all of this open the JKJAV, the Jawatan Kuasa Jaminan Access Vaccine, is mentioned in the AstraZeneca safety sheet. Apa benda yang red flag needs to be immediately being reported because in the case it's been shown that cases in the I think UKs and other countries who had used AstraZeneca, those people who immediately responded with these symptoms were being treated properly. So just to say that now we understand the condition and concern, but all the countries has looked into it. Even Malaysia, we have looked into it, and the scientists abroad has looked into the heterologous immunization using Pfizer and so on. Just because we are concerned about this the rate of clot occurring is low, but there is still there. So that's why there is this kind of race towards looking into heterologous immunization. Malaysia, what are we doing now? We also be very conservative, and what has been done by the government is excellent. And inshallah, we are always looking up at what the decisions by KKM and Muslim.
Okay, thank you, Dr. Muhammad Ashraf. That was very very informative regarding what is happening now in the KKM and all the Jawatankuasa. Would you like to add anything on that, Dr. Leslie? Anything on the thrombosis, and the other one is the what was the question just now? I pun dah lupa.
Yeah, after vaccination, you get.
Yes.
Yeah, I will just touch on the second part of the question.
Yeah.
After vaccination, get infected. This is exactly what Dr. Mariam is trying to do now, is to actually check the antibody level upon vaccination. So we do not know. So if there are deaths after get infected, after vaccinated, you still get infected. So there are a few things that we can assume. So first is the antibodies may have already dipped below the protective level. And the other one is it could be we are dealing with different variant right now. So these are the two possible assumptions that we can make if, let's say, people claim that after they have got vaccinated and still they get infected. So these are the two that I can think of as of now. Yeah.
Okay, thank you, Dr. Leslie.
That's why, Pemusi, that's why I'm telling the kampung people, you know, you bring the box of your medication tu. Kalau orang Kelantan bawa jabir ubat, plastik ubat tu bawa. Jumpa dengan doktor, tunjuk. Ini saya makan apizaban. Saya makan kadiprin. Saya makan warfarin. You see? Then they will decide. You know, because nobody knows what is inside your body. Yeah. Itu mesti.
Okay, we are almost to the end of our breakfast talk. So I have two last questions. That is from the questions that we have set, and also from the chat box. So these two last questions will be, the first one is on herd immunity. That is the first one. And the question is it possible for us to reach herd immunity in our population before 2022? And the second question, which is the last question, is dia kata kat sini pun ada awareness juga, so tak apa, that will be inside the herd immunity also. Future plan is research in vaccine is really important to prevent this kind of pandemic. In your opinion, do you think Malaysia is ready and able to develop our own vaccine? So we have two questions there. The first one is herd immunity, which must also include awareness on vaccination. And the second one is, are we ready? Now that we have the knowledge and the opportunity in this pandemic, are we ready to develop our own vaccine in the future? Can we start with Prof ke Prof nak pass ke Dr. Mariam dulu? We start with Prof.
I will do me, yeah. Because the last one, coffee nak habis lah. Okay. I go for the second question first. Because we start from there. Malaysia has been developing vaccine for veterinary use. Yes. Very long time ago, 1990s lagi. When I was with the veterinary services, we were the center for a regional by the UNESCO to develop vaccine for avian. Yes. And we produce a very good avian vaccine for poultry industry. And this poultry is billions of industry, money for the nation. You know what happened if there is no ayam in the market? You is starving. So it's very important industry. And we produce a very good and all the third country, even the developed country, consume our vaccine. It's just that the regulatory of human vaccine and veterinary vaccine is different. The human is more stricter. So it's not like you are dealing with the animal. So in terms of capability, I think Malaysia is at par with any developed country we can produce. Because I still remember in 1996, we are having an ECP program. It's a Malaysian Technical Cooperation Program. It's the program that we have to help the third world countries. And the candidate who came and learned on with us how to develop, avian vaccine, breeding program, cytogenetics, and molecular genetics. They are from Thailand, from India, from Nigeria, and also the Philippines. Thailand is producing their own vaccine. So I think we are more than that. If we taught them how to prepare something, in the past 20 years, I think we are at par. So it's just a matter of the the agreement by the higher people, by the higher authority, because vaccine development is not 100 million, billions and billions of ringgit Malaysia in the business. If the government didn't put their kind of say, then it won't go lah. So that is the first question. The second question, and the go to the first question, the herd immunity. At the moment, in Kelantan, I don't know about other states. In the Kelantan, up to 18th of June, we just vaccinate around not even 15% lagi. So herd immunity can be evaluated when you reach like 80%, Dr. Maria, kan? Lebih kurang kan? So we are at 50% vaccination. So it's hard for me to say whether we are going to reach herd immunity or not. So I'm passing this to Dr. Maria.
Okay, Dr. Maria, sila.
Thank you, Prof. Actually, to achieve a herd immunity against COVID-19, a substantial proportion of the population need to be vaccinated. But currently, we are uncertain of what the percentage is. For example, in measles, okay, we require about 90 to 95% of population that need to be vaccinated in order to achieve herd immunity. In other diseases such as polio, we need about 80% of population that need to be vaccinated. In COVID, for example, we actually need approximately 75 to 80%, because taking into consideration the people who have been infected with COVID. So they actually also develop some type of immunity. And to talk about herd immunity in Malaysia, that is a tough question, because even in the world, no other country have claimed that they have reached herd immunity. And we also need to take into consideration the vaccine hesitancy group that exists not only in Malaysia but also in other countries. But I guess their percentage is quite low. So there is no actually exact percentage of what herd immunity that we need to achieve. But I think that also depends on the stock of vaccine that we get. If we can actually do the rollout vaccination very quickly, then I think we are protected. But if the vaccination rate is quite slow, then it is difficult to protect everyone. And also the Pfizer vaccine has now been approved for children 12 years and above. So how about the younger group of children? So I guess it's not easy to actually achieve herd immunity because it's a global epidemic. So I think the main point is to get vaccine as soon as possible, and also to adhere to the SOPs, because although you are being vaccinated, you have the chances of of infecting other people who are not vaccinated. Okay, so I think that is the most important thing.
Okay, thank you, Dr. Mariam. What about can we develop our own vaccine soon?
I think I think our government need to actually invest a lot if we want to develop our own vaccine, because the technology is there, but until we invest and actually do a lot of research, it's a tough question to answer, because it's beyond our capability. But I think we have the experts in the field, but we just need the technology. And if we can actually bring the technology from outside, that is a good idea as well.
Okay, thank you, Dr. Mariam. Would you like to add your opinion to that, Dr. Muhammad Ashraf?
Okay, which question?
The first one, the
first-
herd immunity and awareness, and the second one
Okay.
is can we develop our vaccine?
Yeah, maybe just I'll respond to the vaccine first, because
Okay.
here this program is organized by UPM.
Okay.
I think UPM has their researcher who is Dato Paduka Khatijah. I think she is working on the NDV. So she is the professor and the pioneer of the Newcastle disease virus. And I think she has started in March, where she has been given some amount of money to develop the use of NDV as the using viral vector technology. So this is something I think maybe Dr. Leslie is from UPM, right? Maybe wants to respond after this. At the same time, with regards to vaccine development, YBKJ has mentioned that we have a vaccine development roadmap. So this is very, very interesting. And at the same time, I would like to respond and echo to Prof. Shahrul. Malaysia has been involved with vaccine development for 30 years, mostly, and also with KKM, is it? I can't remember, but obviously mostly. For example, they have given numerous grants. I think I've read somewhere that 55 grants. But from among 5 human vaccination project, one kind of succeed. I think it was about cholera. The rest mostly were vaccine successful for animals, as mentioned by Prof. Now, so we have experience of animal vaccine developments. Among the reason were because of the safety and so on. So what the government now is doing is that they are using all the resources and all the network and collaboration to build up the capacity, put or add to what we are lacking. So amongst the things we have seen that this team, IMR, is leading with also one project on using mRNA technology that has started November. YB Adam Baba has just mentioned this announced I think 3 days ago, mentioning that we are developing our mRNA vaccine. That's one. The other one, MR and also UPM, I think, are using another initiative. I can't remember, but also maybe also adenovirus. So that's another one, or viral vector. So we have different technologies. We have now Prof. Khatijah. We have the mRNA, has started about November last year. So now we're waiting for it. At the same time, the vaccine development there's a long phase that is maybe starting preclinicals, but we have also in the far end of production, we have now been, Pharmaniaga is doing the fill and finish, meaning to say, for example, the Sinovac came to Malaysia in bulks. So we do the filling, ni bukan campur-campur air, the sterile condition. So we are now equipped, Pharmaniaga in Puchong, their life science punya factory, they are now very competent to fill and finish into vials. So we are ready for this kind of technology. We are here, we are there. So if you are asking, yes, inshallah, we are ready. The government is putting all out. And for the biomedical science students, get ready. You might be the ones working in this kind of sector. So that's one. The question about tadi apa,
Herd immunity.
What was the question? Herd immunity. Herd immunity is very much interesting. If we look at JAV website, dia dah tambah ada asterisk. Somehow before this, we say the rule of thumb 60 to 70% herd immunity. Now we here nampak tu 80%. Boleh nanti buka JAV. Now the question about how much is the correct number, there's no magic number actually. There's very detailed calculation of using the R0 value and so much. This epidemiologists might be able to respond. Tapi there's a calculation. But kind of the thumb of rules is that rule of thumb 60-70. Tetapi we need to remember that herd immunity, the basic and textbook understanding is that it prevents or it blocks infection and transmission. The problem now is that a person even vaccinated or has already got natural infection still transfer. So that is very dangerous. And I would like to bring into discussion of the Manaus city case in Brazil. So kalau ingat dulu the berita, all the news showing about Brazil, death 120 daily, and up to June 2020, the cases were too high, and about 60% of the millions of the people in Brazil, specifically in Manaus, were infected. Now, 60% herd immunity can come from two ways: natural infection as well as vaccination. So these people already have natural immunity, 60%. Magic power of the herd immunity, kalau kita use that number lah. Now, nevertheless, so and then the after June, the numbers were reducing, and they somehow lifted the movement macam ni lah, PKP and so on. Because the reducing number, magic cannot be going on in Brazil. What happened is that in January 2021, resurgence of cases inclined due to the presence of the P1 variant, which is a Brazil variant. Now, what we can, the theory of herd immunity, yes, it is there, but because of these dynamics, vaccine hesitancy, herd immunity, we can look at it global and as well as local. Tapi no country is isolated kan, we ada traveling and so on. So herd immunity at the very ideal is the global. Now, because of the issue tadi Dr. Leslie mentioned about hoarding of vaccines from the Canada, US and so on, we are lacking in this. And then the efficacies of the drugs to prevent blocking the infection, that's another issue. And there are variants upcoming, that's another issue. So is herd immunity really something that we are kind of relying? But that does not necessitate the kita punya eagerness to vaccine. That's something kena buat. Tapi now we need to take a bit more precaution to bila kita nak think of slowing down the non-pharmaceutical interventions. Masih kena pakai vaksin. Do more arsenals, do more intervention towards the arsenal of pandemic ways of prevention. Not just vaccine, more testing. So now Singapore dah buat screening using IDO, saliva and so on. So these are the necessity. Our goal is not herd immunity because that's kind of now dah jadi blurry. There's lots of debates overseas and an article from Nature talking about this. So I think that's my point. The last one maybe ada satu lagi ada ke?
I'll reserve the last one for Dr. Leslie. Boleh Dr. Leslie? This is a question from Muhammad Aiman Barudin. He asked, is there any opportunity for local biomedical graduates to get involved in training of research project involving immunoinformatics? Hopefully, it could be a good start for in silico vaccine design before getting into wet lab work. What are your opinions on this?
Yeah, thank you for the question. So on that in silico work, I do not have any experience myself, and also I do not have any connection or any person that I know of that is who is actually doing bioinformatics. So I can't really answer the question. So I'm sorry, but maybe as always, we always need to go and look out for that person, whether there are any expertise in Malaysia that are doing that. So yeah, so sorry, I do not have that answer for that. Yeah.
Okay, thank you, Dr. Leslie. Prof?
Yeah, it's a good question. Thank you to the student. That is actually the new area that I think everybody are looking into, especially in this NGO environment, NGO what they are having condition where you cannot go outside, you cannot work in the lab, you cannot even go to the university. They lock down. If you go, your card can open the door. You end up sit down outside. Oh. So the bioinformatics is a very powerful tool. In fact, when the scientists develop the vaccine candidates for AstraZeneca, for Pfizer, it started from the bioinformatics evaluation actually, because when first Wuhan, you still remember that the original strain, which is already now gone, tak ada, at the moment the original SARS-CoV-2 dah gone dah habis dah. I mean, I don't know, maybe they just die like that. And most of the one that we are having now, the one that we are having, the normal strain now is in Malaysia is the B614G. And then plus the variant, you have F alpha, you have beta, the gamma, and then you have a variant of interest. So those are the kind of things. And the good things about this virus is that the genome is very small. So you can basically work without in the lab. You don't need to go to the lab. You just use the sequence of the RNA and search for the spike protein and use bioinformatics tools and get the proper supervisor and the good bioinformatician or structural biologist who can sit down with you. I think in Malaysia we have many universities, a few universities who has a lot of scientists who are in bioinformatics. They can sit down and do the thing, And once, if I still remember, when scientists in Jenner Institute in UK, that was the place where Oxford AstraZeneca punya vaccine candidate was introduced. It was actually coming from the in silico works. They are looking into that was the reason why they start looking into the spike protein. And then after that, the work was actually with Oxford Jenner Institute and also the Institute of Allergy and Infectious Disease in the US, medicine, and then they tried the test the vaccine candidate that they studied on 10 macaca, monyet, and then they had discovered that the 6 out of 10 covered, protected by that was the original story of how AstraZeneca, and after that both US and scientists at Jenner approach AstraZeneca punya company. You need billions money, kan? So that's why I'm really happy when both Yang Berhormat Menteri have a positive say on our own development of vaccine, because without the government support, we won't go into this. Thank you. That's my comment.
Okay, thank you all. Dr. Mariam, please.
We have actually 2 experts in bioinformatics in School of Health Sciences, USM. And we also have an expert in bioinformatics in INFORM, Institute for Research in Molecular Medicine, USM. So I guess those who are interested, they can browse our website and look for the experts. I think they are currently doing some research on this bioinformatics regarding the vaccine genome. Okay, so I think those interested can go to our website. And I would like to add about herd immunity just now. Actually, when we receive vaccine, the most important thing is that the vaccine can protect ourselves. So the second part is we protect the community. So just make sure that ourselves are protected first before we can actually protect the community. So if we can get most of the people vaccinated, then we can actually protect those with low immune response in our society.
Okay, thank you, Dr. Mariam, for the addition to what Prof said. So before we pen off, do you have any last advice, last words on awareness? Maybe Dr. Leslie, last words on awareness. Why must we vaccinate? Some of people, they don't want to vaccinate because they are afraid. So what are your last words of advice?
I think, I mean, if you are against vaccine, I think we need to relook at the reason why you are against the vaccine. So break it down. Don't just let it play and replay and rewind in your mind to spin it down and identify the real reason why you are against the vaccine. So I think that is an advice that I can give. So if you try to be not biased, okay, try to be objective, try to see, I'm not trying to persuade you. I just, all we need to do is just relay out all the data in front of you. So you just have to judge it on your own. And if you still think that it is not convincing, then dig more, dig deeper, you go deep. And then eventually I think you will know that after weighing all the benefits and also the harmful effects, I think you will roughly come to a conclusion that in fact, if you really love yourself and really love your loved ones and the community, I think it is only rational and only logical for you not to actually go against the vaccine program or that effort that is being done. So yeah, that's my final take-home message. If on
awareness. Thank you, Dr. Leslie.
Yeah.
Dr. Ashraf, any last words on awareness?
Yeah, I'd like to. So this is maybe not the advice to those biomedical students all of here, but maybe this can be kind of a TOT for us to become an advocate to advise other people. I have 5 steps with regards to this. First, listen with empathy. Let them ask what is the reason that they don't want to be vaccinated. Just listen with empathy. Don't be judgmental. Listen with empathy, just to know what are the root of concerns for them. Second, ask open-ended questions. Not saying kenapa tak nak ambil. Ask open-ended questions, dig more detail, and never be judgmental of their concerns, saying that, oh, why? That's a silly judgment. Mana ada tak halal, dah cakap. Relax, allow them to tell what is the issue. Let them explain a bit more. Don't be judgmental. So that was the second one. Ask open-ended questions to dig more and without any judgmental. Number three, ask permission to share information, like Dr. Resli mentioned. Do you want me to share some information? So there's numerous data, whether from authority or from influencers who are working in the professional background. They have given all levels of intellectuality, I mean, layman terms and so on. Use those. Even WHO has their Mythbuster punya tab, giving all infographic. So Malaysia ni selalu dia kata tu, bagi gambar, lukis sikit. So it's explained in infographic. So provide to them that information. Number 3. Number 4, help them find the reason. So once you have given the data, like Dr. Leslie mentioned, supaya dia tengok the good and the bads, now they think that, okay, I think this is okay, a vaccine is okay. Help them get a reason. Everyone has a reason to be vaccinated, about love, about so on. Maybe certain people still feel afraid. Now, if let's say there are people that are kind of attached to, well, a religious argument that actually has been sorted out, but let's say they still don't want to follow, even the Mufti, tell them, now Saudi has called you, to what? If you want to go for Hajj, get vaccinated, or else no Hajj for you. But now Saudi only allowed for Pfizer and Pfizer, I can't remember, maybe AstraZeneca. But to say that, oh, you need to do that. For those who wants to go for a trip, the Europe Commission also has been proposing a passport for vaccination, the green kind of certificate. So one day this might be an in thing. So better to have reason to vaccinate now because it's free. So find a reason for them. That's number 4. And number 5, after you've given them the reason, help them, facilitate them to get vaccinated. Some people feel this is too heavy. You need to daftar My Sejahtera. You need to do that, to do this. Now help them. Create your own. Go to kampung. Help people. Tell those. So these are the things. To biomedical students, we are not penghukum. We are not the judges to say you are wrong. You are not. You're not. You don't understand. We help and facilitate. We are the learner. This is our responsibility of knowledge, and hopefully that we can become advocates in this. I also would like to take the opportunity. I'm doing advocacy through YouTube. I've got several interviews regarding to the OC and some of the SOP and so on. Do subscribe and have a check. Dr. Ashraf Rostam. So that's all. Thank you.
Thank you so much, Dr. Ashraf. Any last words on awareness, Dr. Mariam?
Thank you, Prof. Sabrina. I guess all has been mentioned by Dr. Ashraf. Okay, for the student, you can follow me on Twitter as well. I'm part of MedTreat My member. So we also share information regarding health and medicine with the public. So there are a lot of information in the social media right now. So it's just your effort to look for those information and be a great scientist and be a good citizen. Thank you.
Thank you, Dr. Mariam. Finally, Prof. Shahrul.
Yeah, they have already, tell everything that everything is well explained by Dr. Leslie, Dr. Ashraf, Dr. Mariam. I just want to for the undergraduate students, if you really we want to make use of this condition, please make sure you because when we develop our own vaccine, we need immunologists, we need biomedical scientists, we need those who, the mRNA too, they are encapsulate, they encapsulate in a nanoparticle. So you need nanotechnologies. So you need to have somebody who really look into that material, everything. So and then you have people in epidemiology who are good in bioinformatics. So there are so many areas that you can jump into, and I think all the 5 RUs, we have enough experts in any area that you are thinking of. So good luck, and saya tak ada Twitter, orang tua tak ada, Prof. tak laku. But anyway, hope that everybody will be successful in their future, and hope to get another jet from Malaysian punya biomedical product, inshallah. Thank you.
Inshallah. Thank you so much to all the panelists. I am so honored to be a moderator. So please forgive me, and I do apologize for any shortcomings. So I do apologize for the organizing committee for taking too much time. So thank you so much. Thank you again. Assalamualaikum, and over to you, Crystal.
Thank you so much.
Wow. Thank you very much to all the panelists. It's such a fruitful and impactful talk on the COVID-19 pandemic that we are facing now. I hope everyone benefits and gain a new insight from it as well. So thank you very much to all our awesome panelists and moderator for the great session.